Hi everyone, we are looking at page 142 of a 3B workbook on area parameter, the math journaling task for today. Now this is the last activity of the whole chapter. In fact, it was one of the first activity that started the chapter introducing area and parameter. So it is quite an interesting one to close the chapter. Now in this question, it talks about the story of Janice. Janice having a rectangular photograph. She thinks that the area of the photograph can be found by pasting some sticky notes to cover the photograph. So she wants to find the area. And by now we have already learned a few things. What area means, being the space taken up by the shape, the inside of the shape, and using unit squares, meaning every square having the same size, to find the area. Now over here, Janice used the sticky notes to find the area, and that's the picture that shows how she did it. And she says that the area of the photograph was 8 square units. So she counted 1, 2, 3, 4, 5, 6, 7, 8. And she says 8 squares. Because there are 8 post-its that she used, so altogether 1 square sticky note is 1 square unit. So 8 squares here will be 8 square units. And the question asks you if you think Janice's way of finding the area is correct. And why is it and why is it not? I bring us to the attention to right to the front of this chapter in our textbook, the example on using the handphone cover to cover the handphone. So you would like to have a cover that covers exactly, okay? And I think we have already revisited some of the points there. So I'm going to demonstrate this again with post-its I have sticky notes, and I also like to offer you a bit of extension of thought, of concept, so you can actually have a little bit more questions probing through your head regarding this chapter. Okay, so over here I'm going to use some post-its. Okay, there's post-its here. I bought it, and there's some origami paper here, square origami paper, very colorful ones, and we're going to use this to find the area of the rectangular photograph. In this case, not the rectangular photograph, but let's use my workbook, okay, to like the rectangular photograph, like this. Okay, so you have the workbook with you. You can have this. You can do this activity on your own at home as well. Okay, if you don't have rectangular pieces of paper, you can use A4 paper to cut it out. Or you can buy them. They're not too difficult to be purchased. So I have a stack of post-its here and origami paper. Interestingly, I would like to ask to have some thought about it. Okay, this is the extension activity. So I put the origami paper aside first and take out the post-its, and I would like to recycle the post-its later, so I'll try to do it nicely and gently. Okay, so here the first piece is folded so that it has this effect. Oh, quite pretty, this post-its. Okay, so over here each post-it is a square. Okay, so I will not use this one, it's folded. I'll just take one from here, and I will recycle them later. Okay, so they're blank post-its. So each post-it here is a perfect square. So let's say 1 square is 1 square unit. Okay, so I'm going to paste it on the workbook. Now maybe throughout this time when you're pasting the workbook, you can think if what I'm doing is correct. So let's say I paste it like this, and I paste it like this, and like this. Any problems so far? You think it's okay? Here. It's correct. It's good. Probably I hear some voices. Even this comments here. I think someone wants to leave comments already. No, you shouldn't be leaving any gaps here, someone says. Yes, so the first point here, I can't have any gaps here. This is not really finding the area of the workbook cover here there's lots of space and gaps here, so it's not really occupying the space. So by right we're not supposed to leave any gaps here to be really accurate in our measurement of the area. But to have a good estimate, we try our best to make it as close as possible. So I make sure I try to make sure there's no gaps in between the post-its. Okay, and like this. Okay. Yep, no gaps. Ah, there's one sticking out here. I can just overlap here. Is that correct? Is okay? I like how Janice did this anyway. Right, she did this, right? Just overlap things sticking out, right? Do you say no, can't do that? Why can't you do that? Yes, you're right. Because you can't count that as one anymore. Yes, that's very valid point. Right? So that's what your friend will probably be telling you. No, you can't overlap. Because it's not a full piece of paper, square piece of paper. It's unfair. You know, you have an overlap here. So that's not very fair. Okay, but this is sticking out. So that's not very accurate either. But let's just try our best to make it as close as possible, as much as possible. Balance has been as accurate as how I can use the squares to do these post-it squares. Okay, so as much as possible. So I have still some gaps here. Any suggestions? Okay, this is not right. Okay, so take it out. Okay, can this do? Count as one. It's a bit sticking out. So it's the closest estimate, I say. Okay. I think some of the friends have a good idea. Let's fold it and make half post-its. Okay, I like that idea. Let me give you a snip. I fold into half. Oops, brush it and then snip it. Okay, not perfect though. You see there's stump here, space here. Still, there's a streak here, and I take another one. So I make halves, and well, can we say that? You see, yeah, I have the best possible estimate here, and I have a bit of it here, a gap here. Can I say maybe if I cut these strips out that's sticking out here and put them here, maybe it makes the space? Yeah, maybe. So I cut these squares and I pick. Yep, as close as possible. Yeah, as much as possible. I make them fit entirely. Yep. So you see, it's this is the closest estimate that I can get. But you see, these snips of paper were from the sides here. Okay, I'm gonna get rid of this one. And yeah, about thereabouts. So my best estimate is I have 1, 2, 3, 4, 5, 6 full squares, and then 1, 2, 3, these trees belong to them. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half, and about 10 and a half square pieces of paper. So 10 and a half square units, I would say, post-its. That's the best estimate I can get. Okay, so I actually snipped it from the original post-its to make up the gaps. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 and 10 and a half a bit. Right, so that's the best possible estimate I can get out of this one. And I snipped it off the original squares. So yeah, so overlapping doesn't count. That isn't right. So this is probably the best estimate. Well, maybe my next question would be, what do you think? How can I then be more accurate? Instead of like having to, you know, make do with snipping big squares post-its. I like what some of you have in mind already. Okay, so I'm gonna remove this, and let me use the other side of the book, right? Okay, and yeah, some of you, I think you got it right. Maybe to be more accurate, I need smaller post-its. I think that's a great idea. I need smaller squares to just like the little ones just now, right? When I have a smaller squares, it gives me a better measurement, right? A closer estimate. So, but then the point here is, imagine I'm going to use bigger papers here, like this one, bigger squares. Do you think I will get a bigger answer of for the area, or a smaller answer for the area based on the squares here? Okay. So some of you say, I'm so sure. No, don't know about that. Okay, I'm going to use the brightest color here, pink. Okay, and see, if I'm going to use big squares, the origami paper here, okay, it fits really nicely. Okay, I'm getting into trouble here again. I probably have to half the paper again. Snipper for the bottom here, and it probably won't be accurate again, right? So let me just snip it off here. And I cover, and yeah, still I'm not covering the whole workbook here. There's a bit here left, but this came from the same origami paper, so it's about 3 big squares. So some of you got it right. So if I'm going to use a bigger unit to represent, the number of square pieces of paper actually gets smaller. So in other words, if I'm going to use a very small square unit, like just now the one that we did in our activity, tiny squares, the number of squares that needs to form up the whole workbook will definitely be bigger, right? Okay, so that's got to do with the accuracy of measurement. So that's why I think some of you have in mind already that instead of going through the hassle of, it gets confusing. That's the reason why we have standard units actually. So imagine you buy things and someone says, I base it on the size of my hand, my daddy says my hand size, my face, this area of my face is about the size of my daddy's hand. Then, okay, but if it's your own hand, is it fit the same way? No, right? So because of the difference in the units that we're using, your hand size and the daddy's hand size might be different. So that measurement will not be accurate, and that's why eventually these things like a ruler is invented. So I'll be able to find the area of the workbook here with greatest accuracy by using a ruler, and then I'll multiply using the formula of length times breadth. Right? Okay. I hope you have some fun doing this activity at home using post-its. Okay, and you are able to answer the question on page 142 of why you cannot use, why Janice's method of finding this is not so correct. Okay. Alright, thank you for watching this video.